Hello, welcome back to our continued discussion of using cylindrical coordinates to find volume. Remember, for cylindrical coordinates, we really like circular bases, and that's what we have for our next example. We want to find the volume of the solid region Q cut from the sphere centered at the origin with a radius of 2. And we're going to restrict that to the cylinder r equals 2 sine theta. Now this is going to be our base. I know that because this is a polar coordinate and this is going to be on the xy plane. So, whoops, there. No, can't spell plane very well today. There we go. Plane. So let's kind of see what this looks like if we were to graph it out. So to graph r equals 2 sine theta. So let's review that. That is a polar graph on the xy plane, and it's going to look like this with a diameter of 2 right there. So that's how we would graph this r equals 2 sine theta. So on my three-dimensional graph, it would look like this with the radius of 2. Diameter of 2, sorry about that. Now, what we're going to do is now we're going to graph our sphere. Now our sphere also has a radius of 2, and it goes like this. There's my sphere, not the best sphere, but be careful, they say between the sphere. They didn't say just the top part of the sphere, they said the sphere of all. So, like Roosevelt once said, we have nothing to fear but spheres themselves, right? So, I have the bottom half of the sphere I have to worry about as well. So then we're going to project. Remember, this base, this circle here, is going to be projected to our surface. But this time, it's going to go up and down. And we want to find that resulting volume. So this is not really hard to do. So let's talk about the limits. Well, the first limit we're going to find is our change in z. Well, let's go ahead and get that. Well, the change in z deals with my sphere. This is going to give me my height. This is my height right here. And I can write this equation as x squared plus y squared plus z squared equals 4. Now I'll get the equation of my sphere. So my minimum z would be the bottom half of my sphere. So if I look at this, this is saying x squared plus y, I can solve this. For z, I would get z equals plus or minus the square root of 4 minus x squared minus y squared. So this would be, the bottom would be this negative square root of 4 minus x squared minus y squared, and the top would be the positive 4 minus x squared minus y squared. Now, I have to find my change in radius, delta theta change in radius. To do that, I go back up to my polar. So if I look at my polar, starting at the center, we go out to r. So my minimum radius will be 0. My maximum radius will be the surface itself. Remember, these are dealing with our base, which is our xy plane. So my minimum radius will be 0. My maximum radius will be the circle 2 sine of theta. Now this is the part that's going to be a little bit tricky for us. This circle right here only goes from 0 to pi. Theta here goes only from 0 to pi on this type of circle. So my change in theta goes from 0 to pi, not 0 to 2 pi. If you did that, you'd be going around twice. Please take a look at your old pre-cal notes or my old videos on pre-cal and polars and pre-cal, and you can take a look at that. Now, here's the problem. So we have our height, we have our base, but notice polar, polar, rectangular. That is not a good combination. So we need to convert our height to polar, and I can do that up here. So we would have z equals plus or minus. If I factor out the negative, I get 4 minus x squared plus y squared. And we know that x squared plus y squared equals r squared. So this would equal plus or minus the square root of 4 minus r squared. So this would be the negative square root of 4 minus r squared, and this would be the positive 4 minus r squared. And now when we write our volume, do your triple integral, be careful, r dz dr d theta, order matters. My change in z's, we just said, is negative square root of 4 minus r squared to positive square root of 4 minus r squared. My change in r's goes from 0 to 2 sine theta, and my change in theta goes from 0 to pi. And there we have that. All right, so for our next one, we just want to convert this into a cylindrical coordinate. Now be careful, notice everything is rectangular. We will have to convert this. So let's go ahead and do that conversion real quick. X, y, z would equal, well, we know x is r cosine theta, y is r sine theta, z, we can't do anything with it. Remember, that's our rule, our conversion up here. Z just stays z. Z's got a z, man. So this just stays z. And if I simplify that, this becomes r squared cosine theta sine theta and z. All right. So we've just did that conversion here. But now we have to take a look at our domains here, our region here, our base. So let's see here. Alrighty. Let's sketch the region. All right. So the z right here, this is just my height. So I am going to look at my base. I'm going to convert my base. Alright, so let's see here. This is going to be on the xy plane, and I know that because this is dz, dx, dy. So xy. I know that my change in x's, my change in x's go from 0 to the square root of 1 minus y squared. Well, this is just the left, not the left, the right part of a circle. Okay, so my x is going to go from 0 to this circle with a radius of 1, like so. My change in y goes from negative 1 to 1. So from negative 1 to 1. So we're looking at this part of a circle being converted into a polar equation. So let's write this as a polar graph right now, as polar. I need my change in radius. Well, my change in radius only goes from 0 to 1, so it's going to be from 0 to 1. And our change in theta, be very careful, I'm starting at the bottom and I'm starting at the bottom and we're rotating around. So theta starts at negative pi over 2, the easiest way to do it, all the way to pi over 2. So let's go ahead and write our volume. We're going to use a triple integral. Now I know what you're thinking. You haven't changed the z's yet. So that's okay, we'll talk about that. So I'm going to go ahead and rewrite this. Remember, all of this goes in here. This is my x, y, z. So this is going to be r squared cosine theta sine theta times z. Now, and so times z, so that all goes in there. R dr, oops, sorry, not dr, dz dr d theta. Okay, be careful, order does matter. Don't forget the z, don't forget this r, and you can multiply those two right away and get r squared. Don't forget this, okay? This would be distributed in. But now let's take a look. Let's just do our dr d theta first. We know r goes from 0 to 1 and theta from negative pi over 2 to positive pi over 2. But what about this? Well, that's easy to do. X squared plus y squared is r squared, so this is just r on top. And the bottom, x squared plus y squared, this is r squared. So the bottom is just r squared right there. Those are easy to convert. So you do have to convert everything in terms of x and y. But really look at the base. Start with the base. Makes it much easier. And there is our volume right there. All right. Hope you guys enjoyed the video. I will see you in the third video for the last question. See you soon. Bye-bye.